In this video, we're going to do a quick demo of the Desmos graphing calculator to see how to do transformations using the vertex form, so several transformations at a time as opposed to just stretching, compression, or translation all one at a time. We're doing it all at once. So the previous video showed you how to do it by hand. This is a great way to just verify your work to see if you're on the right track and to see if the graph actually makes sense. So the example we're going to do is from your notes. We had, just going to write it out here, negative 2, oh, that's a bit of a thick marker. Let's make it a bit thinner here. Let's erase that. So we had negative 2x minus 4 squared plus 8. So the idea is that we're going to first put our y is equal to x squared in. Y is equal to x, and then let's square that. Let's square that. And so here's our parabola of y is equal to x squared. And we're going to do our transformations now. So you'll notice that we have a stretching that happens. So what we're going to do is we're going to do our y is equal to 2x squared. So y is equal to 2x squared. And so you can see the stretching happened. We're moving up twice as fast for every x value that we move. And so our graph, our parabola is now narrower. But then you'll also notice that there's a reflection that happened as well. So we're going to do that in our next transformation. So we're going to take this same graph here, and we're going to put the negative in the front. So now, if you look carefully, let's zoom out a bit, we took this one here, 2x squared, and reflected it about the x-axis by applying that negative. So now we need to take a look at any translations that have happened, and there's actually two translations that happened. There's a horizontal one and a vertical one. So what we're going to do is we're going to put that horizontal translation in for our next graph, and so it's going to look something like this. We're going to have negative 2 in the front, x minus 4 here. Now minus 4 really means that we've moved 4 units to the right. I'm just going to put the square there to make sure it is a parabola. So you'll notice we took this one over here, we moved it 4 to the right. So we did 1, 2, well, this would be 1, 2, then 3, and 4, because each grid here, each unit represents the movement of half. So half 1, and then 1.52, 2.53, 3.54. So we moved it to the right, but you'll notice that's not our only transformation there. It's not our only translation. Another translation that we do is the movement upwards by 8 units. So we're going to take this graph now and move it up by 8 units. So like that. And then we're going to add the plus 8. And, oops, not plus 7, plus 8. And you'll notice now that our graph has been moved up by 8 units. So this over here was at 0, and now we're all the way up here at 8. So you can see the 0.00 and then the 0.48. To analyze the points, you click on the graph that you want to study, and you can go and take a look at some main features such as a vertex here. Over here, the vertex is up 8 units. So again, this is a great way to practice doing those transformations one step at a time, all on the same grid. You can zoom out to see them more effectively and be able to spot them. So you should know by now that, this red one here is y is equal to x squared. This is more narrow. As a result, that was probably the stretching that was done. Then we flipped that stretching. Now it's below the x-axis. And then we move this one over to the right by 4 units because of the h, which was 4. And then we move this one here up 8 units because of the k, which is plus 8. So again, try this for the other examples in your notes after you've done them by hand, just to compare and to see if your answers are on the right track.